Okay. This is the easy part. The back half of these notes are easier. The integral of 3x to the 4th. My new exponent needs to be what? 5. Okay, when you integrate, you go up an exponent. And I'm going to keep the coefficient, but you have to divide by your new exponent. Because, go backwards. Take the derivative of 3/5 x to the 5th. What is it? 3x to the 4th, which is what I started with. Okay, good. All right, minus 5x to the 3rd, but I need to divide by the new exponent. So 5/3 x to the 3rd. What's the integral of x? 1/2 x squared. Plus c. Good. Okay? 1 over x to the 4th. Let's rewrite this. How do you want to rewrite that? Okay. Whoa. X to the negative 4 dx. Now, when you rewrite it, you still need to put your integration symbol, the big funky s, and the dx. Okay? Bump our exponent up by 1. Negative 3. And then we can either think of dividing by negative 3 or multiplying by the reciprocal, negative 1/3. Yeah. I think of it more in terms of multiplying by the reciprocal of the new exponent. When you rewrite it, well, but just, well, you're not ever going to have to rewrite that again. But, I mean, the only thing you're changing in part B is the 1 over x to the 4th. So just remember to rewrite everything else that's in it. All right. C. Do you want to rewrite that in any way? Yeah. I want to rewrite that as x to the 1/2 plus 2 sine x. Now, these parentheses are important because it means that whole quantity is the derivative. It's kind of, you would distribute that dx all the way through there. So the parentheses are kind of important. All right. What's the integral of x to the 1/2? 2/3 x to the 3/2. Good. Start with, the way I start is your new exponent is up by 1, so that's 3/2, and multiply by the reciprocal. This doesn't look like a 3, but it is. All right. What is the integral of 2 sine x? Negative 2 cosine x plus c. Yeah. Yeah. It's just equals 2/3 x to the 3/2. Okay, there is no product or quotient rule for integrals. So you have to simplify before you integrate. You can't just integrate the top and integrate the bottom. At this point, it's kind of like we're just using the power rule, the reverse power rule of derivatives. So I need to rewrite d as x over the cubed root of x plus 1 over the cubed root of x dx. Okay, I didn't write this very well. Okay, this is like x over x to the 1/3. So x to the 1st over x to the 1/3 would be x to the 2/3. And then 1 over x to the cubed root of x, or 1 over x to the 1/3 would be x to the negative 1/3. Okay, now don't forget to integrate. We've just rewritten it. All right, x to the 2/3. The new exponent is 5/3, so I need to multiply by 3/5. Okay, x to the negative 1/3, the new exponent is 2/3. So I need to multiply by 3/2 plus c. Like right here, all I did was separate the numerator. I put x over the denominator plus 1 over the denominator. X over the cubed root of x plus 1 over the cubed root of x. Okay, on E, can we use trig properties to rewrite that somehow? Sine over cosine is what? Tangent. And another cosine on the bottom is secant. So this is really the integral of secant x tan x. And what has a derivative of secant x tan x? Yep, secant x plus c. I one time had a kid take a test, and there was the whole problem that involved secants. And he probably had to write secant x 6 times, maybe 10 times in the problem. And on every single one, he left the c off. All right, 4. The general solution, he was kind of embarrassed. The general solution of dy, find the general solution of dy dx, and then find the particular solution that satisfies the problem f of 2 equals 4. All right, if I cross multiply here, this is called a differential equation, and that means find the function whose derivative is listed here. If I cross multiply, I get dy equals 3x squared minus 1 times dx. Y'all cool with that? Okay. Now I'm going to integrate both sides. The integral of dy is y. It's the integral of 3x squared. X cubed minus, what's the integral of 1? X plus c. Okay, that is called the general solution because we've got that plus c in there. Now find the particular solution that satisfies the condition f of 2 equals 4. So that means that when x is 2, y is 4. So what does that allow us to solve for? C, right. So plug in the 4 for y. 2 cubed is 8 minus 2 plus c. 6 minus 2, c is negative 2. Now, the general solution is rewriting x cubed minus x, and then instead of plus c, putting in the minus 2. Yeah, that's the particular. And that kind of makes sense. I mean, general, c is in general terms. When you actually find a value of c, then it's a particular equation.
What is the big F?
Big F is usually represents that that's the integral, or that's the original function whose derivative you were given.